ಒಂದು
Good morning, all of you. So in the previous class, we discussed about some examples regarding fuzzy logic. Right? So in today's class, also discuss some examples regarding fuzzy systems in fuzzy logic. Right? So with the examples in fuzzy systems, we discussed an example regarding air conditioning, that is the AC. This air conditioners. So compared to the old air conditioners, today we are using inverter ACs, right? So this is what the inverter ACs doesn't stop the or doesn't switch on or switch off the compressor many times. Okay, so based on the environment, that means compared to the old ACs, that means those old ACs were set to a minimum temperature and maximum room temperature. Okay, so when that particular number reaches, for example, if the lower number reaches, then the unit gets turned off, and when the upper number reaches, then the unit will turn on. Okay, right. So like that, the total unit will switch on or switch off when the temperature reaches either to the lower value or to the upper value. Right. Whereas in today's ACs, fuzzy logic doesn't rely on the two extremes. That is the minimum temperature or the maximum temperature. So it doesn't rely or it doesn't depend on the um, temperatures. Okay, maximum or minimum temperatures. Right. So it manages the temperature to remain steady. That means it stays at stable temperature, or it remains steady regarding the temperature. Okay, that means uh, it doesn't depend on the maximum temperature or the minimum temperature, just remains steady. Okay, so while it senses the environmental temperature, so it keeps on the AC at steady temperature only. Okay, so by sensing the slight fluctuations and making adjustments, the AC is more energy efficient. Okay, so like that, the fuzzy logic is used in ACs. And next, coming to the cooking, and the example is cooking. Okay, so in this particular cooking, it needs to get the rice cooked to the right texture and moisture. Okay, so there is no human involvement there, just only the device where rice was kept. uh, where the rice is kept is will cook the food. Okay, so uh, so it should be at right texture and it should have right moisture also. Okay? Right, so just we're going to place the rice in the rice cooker. Okay, so this particular rice cooker um, uh, checks whether the rice is to be cooked fast or slow. Okay, so if the rice is cooking too fast, that is based on the situation present in the rice cooker, it is going to cook the rice, right? So if the rice is cooking too fast in the cooker, then the fuzzy logic algorithm present in the rice cooker alerts the computer to turn down the heat. That means the rice is cooking fast, then it turns down the heat. Okay, if it senses the moisture is not being absorbed at the right rate, that means if the moisture not well in the is not well in the rice cooker, then the computer increases the heat. Okay, right. So every fluctuation in the cooking process triggers an if. That means if this is the case, then do like this, and if this is the case, then do like this. So it is the if then case here. Okay, so every fluctuation in the cooking process triggers an if, and an algorithm answers with then. Okay, na? Okay, so that's it. Right. Next, next example is washing machine. Okay, so this particular washing machines also use fuzzy logic only. Okay, so they can sense how heavy a load is and determine the correct amount of water and detergent, speed of agitation, and length of the wash cycles. Okay, so all these will be kept. Okay, so all these will be kept in the washing machine. Okay, so just we switch on the washing machine, we put on the mode present over there. So just now the washing machine will searches for the number of clothes that are put in the washing machine, and how much water and how much detergent are to be allowed. Next, with how much speed the washing machine is to rotate, and how many wash cycles it has to uh, do. That is, or for how much length of time it should take to wash the clothes. All this will be inbuilt in the washing machine. This based on the mode where we have selected there. It keeps on reviewing all these. That is the amount of water and detergent. Next, at what speed, and for how much time it has to wash the clothes. Okay, all these will be sensed by the washing machine. Okay, and it searches for the load also. That is how much load has been kept on the washing machine. All this. Okay, so there is no single standard for the dirty laundry. Okay, fuzzy logic enables the machine's computer to make in between decisions. That means here also it senses the um, senses all these. Okay, so the fuzzy logic enables the machine's computer to make in between decisions. That means the clothes are very dirty. Then um, that it for example, if the laundry or if the clothes are very dirty, then the fuzzy logic enables the machine's computer to make in between decisions. That means in between means in between, if the dirt becomes clean, then it changes its decision. Okay, that means based on the situation present over in the washing machine, it is going to take decisions. Okay, right. So at the beginning of the wash load, the water is clear, right? So at the beginning, the water will be clear, right? Next, as it becomes dirtier, the machine's computer senses the discoloration that does not allow light to pass through as easily. the sensors use fuzzy logic to control settings, so you can get a clean load. Okay, that means whenever that means at the beginning of the wash load, obviously the water will be clear. So whenever the dirt is being removed with the water and the detergent present over on the washing machine, so the water becomes dirty. So the particular dirty water has to be pumped out of the washing machine. Okay, like that. So it takes decisions based on the situation in the washing machine, right? So so now the computer senses the discoloration of the water, and it does not allow light to pass through as easily. Okay, so the sensors will use the fuzzy logic to control the settings so that you will get the clean load or clean clothes. Okay, right. So that is regarding washing machine example. Next, coming to the TV. TVs. So this particular fuzzy logic is also used in TVs. Okay. So similarly, televisions control the screen's brightness, automatically adjusting the picture when light is streaming in or the room is darkened. So based on the environment or based on the room situation, so the screen brightness will be increased or decreased. So that particular sensing will be done using fuzzy logic only. Okay, in the TVs. Okay. Next, coming to the next one. This example, law enforcement. So it's also used in law enforcement. Okay. So this particular law enforcement software leverages the power of fuzzy logic to narrow down possible suspects in a database. Fuzzy logic reflects that there are degrees of truth. That precision comes from a series of decisions, and solutions require solid decision making. So this is also used in law enforcement. That means based on the suspects or based on the degree of truth or based on the series of decisions and solutions present over there, it takes the solid decision making. So this particular law enforcement software uses all these. Okay, so this also uses fuzzy logic only to narrow down possible suspects in the database. That means, for example, if some 10 people are there who are suspects in the database, who are suspects for a particular crime, so it searches for the degrees of truth there. Okay, so based on the degrees of truth, it is going to narrow down, or it is going to decrease the number of suspects. Okay, so that is in regarding the software that is used in database. Okay, right. So we started with barcodes, but we have grown and expanded over the past decades. So initially it was started with barcodes. Okay, but now okay, so that's it, right? So this is regarding some of the examples where fuzzy logic is used. Okay, right. On just give me a minute. I'll be back. Please don't go away. Please stay here only. Now, let us see some more examples here. Right. So, let us see some more examples here. Right. So, this is one of the applications of fuzzy logic. So, the fuzzy logic is used in various fields like automotive systems, domestic tools, environment control, etc. So, now some of the common applications where fuzzy logic is used is it is used in the aerospace field for altitude control of spacecraft and satellite. That is in aerospace. Next one is this controls the speed and traffic in the automotive systems. Okay. For example, washing machine, TV, all those, right? Next one, it is used for decision making support systems and personal evaluation in the large company business. So this is in decision making systems. And next one, it also controls the pH value, uh, drying, next chemical distillation process in the chemical industry. So it is used in chemical industry. Next one, it is used in natural language processing, where intensive application, where and various intensive applications of artificial intelligence. So it is extensively used in natural language processing and AI artificial intelligence applications. Next, it is used in modern control systems such as expert systems. And next one, uh, so it is used in neural networks also. Okay, so fuzzy logic mimics how a person would make decisions, only much faster. Thus, you can use it in neural networks. So these are some of the common applications of fuzzy logic. Okay. Now let us see some advantages and disadvantages of fuzzy logic. So these are the advantages and disadvantages of fuzzy logic. So coming to the advantages, the structure of fuzzy logic systems is easy and understandable. Next, it is widely used for commercial and practical purposes. Next, it helps us to control the machines and consumer products. Next, it helps us to deal with the uncertainty in engineering. Next, it is mostly robust as no precise inputs are required. Next, if the feedback sensor stops working, you can program it into the situation. Next, you can easily modify it to improve or alter the system performance. Next, inexpensive sensors can be used, which helps you or which helps us to keep the overall system cost and complexity low. Okay, low complexity and system cost to be reduced. Okay, system cost and complexity to be reduced. Okay, these are some of the advantages. First one is easily understandable. Second, next one is it is used in commercial and practical purposes. Next one is to control the machines and to control and in consumer products we're going to use this. Next, in order to deal with the uncertainty in engineering, we use this. And next, it doesn't need a precise inputs, so it is robust. And when the sensor, the feedback sensor stops working, then we can program the situation. Then we can program it based on the situation present over there. And next one, it is easily modifiable when we want to improve or alter system performance. Next one, so We can use inexpensive sensors also here to keep the overall system, or to decrease the system cost or the complexity. Okay, so not only expensive sensors, we can also use inexpensive sensors also for reducing the system cost and complexity. Okay. Along with the advantages, we have some disadvantages also. The disadvantages here are fuzzy logic is not always accurate. So the results are perceived based on the assumptions and may not be widely accepted. Okay. So this particular results which we get from the fuzzy logic is not always accurate. So it is sometimes accurate, but not every time. Right. Next one is it cannot recognize the machine learning as well as neural network type patterns. Okay. So machine learning patterns and neural network type patterns are not recognized by the fuzzy logic. Next one is validation and verification of fuzzy knowledge based system needs extensive testing with hardware. Okay. Validation and verification of fuzzy knowledge based system needs extensive testing with hardware. That means more number of testing methods are to be used for validation and verification of fuzzy system. Right. Next one is setting exact fuzzy rules and membership functions a difficult task. Okay, which means so we cannot set exact fuzzy rules, or we cannot use exact membership functions, which is somewhat difficult task. Okay, next, sometimes the fuzzy logic is confused with probability theory. So when we mix the probability theory with fuzzy logic, then it leads us to some confusion. Okay, so these are some of the advantages and disadvantages of fuzzy logic. Okay. Okay. Oh, now let us see one a real world example here. So this is the example regarding the process control. Process control. Okay. So now let us go through the example. So fuzzy logic in AI. Right. So the design of fuzzy logic system starts with a set of membership functions for each input and a set for each output. That means for each and every system, we have some set of membership functions for each input. Okay, for each input, we have a set of membership functions and a set of output will be there for each and every membership function. Okay, now set of rules is to be applied to the membership functions to yield a crisp output value. So first we need to have a set of membership functions for each input, and for each input we are going to get one output, and to that in order to get a crisp output value, we need to apply a set of rules to the membership functions. Okay, so this is the process of applying the fuzzy logic in the fuzzy logic system, right? Now let us consider, now let us see each and every step one by one. Okay, step number one is, so here I'm considering the temperatures here in order to control the fan speed. Okay, right. So here the temperature is the input. So the input is the hand temperature here. Next one, fan speed is the output here. So based on the temperature we have at that place, the fan speed is going to be in low mode or medium mode or high mode. That's it. Okay. So that is the here the temperature is the input and fan speed is the output here. Okay. Now we have to create a set of membership functions for each input. That is, for each input means for each temperature. So it may be either cold temperature or hot temperature or normal temperature, like, okay, right. So a membership function is simply a graphical representation of fuzzy variable sets. For this example, we'll use three fuzzy sets or three fuzzy inputs. That is cold, warm, and hot. Cold, warm, and hot. Okay. Next. So after considering these three fuzzy sets or three fuzzy inputs, we need to create a membership function for each of the three sets of temperature. Okay, here I have three sets of temperature, that is cold temperature, normal or warm temperature, hot temperature. These are the three types of temperatures here. Okay, now so this is how to draw the graph. Okay, So cold means in between 0 to 50, and warm means in between 40 to 75, and hot means in between 65 to 100. So this is how the range of temperatures are. Okay, and next one is step number 2. So first we have considered all the membership functions here. Okay, right. So here I'm considering three inputs, that is cold, warm, and hot temperatures. Those are the three fuzzy sets. Next one is step number 2 is the next step we will use three fuzzy sets for the output. So these are the inputs here. That is the cold, warm, and hot. These are the temperatures, and these are the inputs here. Okay. Next one is outputs. So we need to use three fuzzy sets for the output. That is slow output, medium output, and fast output. These are the three types of outputs here. Next, a set of functions is created for each output set, just as for the input sets. A set of functions is created for each output set, just as for the input sets. Okay. Next one is step number. So this is the. So this is the. So here percent and temperature. Here the percent and speed. So this is the fan speed. Okay. This is the fan speed. Slow speed, slow fan speed, or medium fan speed, or fast fan speed. Based on the situation present over there, the fan will move at slow or medium or fast. Okay. Next, step number 3. Now we have to define the membership functions. We have to define the membership functions. So we can create the rules that will define how the membership functions will be applied to the final system. Now let us consider three. Let us create three rules. If it is hot, then the fan is to be moved fast. Next, if it is warm, then medium speed. And if it is cold, then slow speed. So this is nothing but the based on the situation present over there, or based on the temperature present over there, the fan should move. Okay. So if the fan moves fast, if it is hot, and the fan moves at medium speed when it is warm, and the fans moves at slow speed when it is cold, like that. Okay. So see this one. Okay, like this. Okay. Now, so like this, the graph is to be drawn here. Okay. Next one. These rules apply to the membership functions to produce the crisp output value to drive the system. Okay. In order to get the crisp output value, we need to apply the rules to the membership functions. Then we are going to get the crisp output value. Right. So thus for an input value of 52 degrees. Now the temperature is 52 degrees. Right. So we have to intersect the membership functions here. So when the input value is 52 degrees here, then we need to intersect the membership functions here like this. Okay. Next one. Here we are applying two rules as the intersection occurs on both functions. We can extend the intersection points to output function to produce an intersecting point. Now we need to calculate the output functions at the height of the intersecting points. Okay, like this. Next. Okay, so this is the explanation of how the fuzzy logic system works. Okay. So in the real world system or in the real working system, there will be many inputs and there's a possibility of getting several outputs here. Okay. That's it. Okay. Now let me see how many have attended my class. Today in total only 62 are present today. Somewhat better, but the number should increase. Right. So 62 members are present today. I once again request all the students to submit your assignments at least today. Many of the B section and C section students have not submitted their assignments till now. Some students are pending in submitting their assignments. So I once again request all the students to submit at least today your assignments, because I need to submit the marks today only. Today, today only I need to submit your assignment marks. So I once again request the students who have not yet submitted your assignments, please submit today. Otherwise, I need to keep you zero for your assignment, right? So we don't want to keep me zero. Just you need to submit your assignments, right? Thank you. If you do not submit your assignments, I will mark zero for your assignments. So please keep it in mind and at least submit your assignments today, right? Today is the last date for submitting your assignments, and I need to mark and I need to put marks for your assignment today only. Okay, so I need to submit the marks to the department today only, right? So please keep it in mind and submit your assignments.